Hello everyone. I hope all of you are doing great. All of you are safe and healthy. Your loved ones are healthy, and you are having a great learning. So, as many of you suggest, and there are a couple of requests, comments about the that we want to know about the CAD industry, the CAD development, CAD tools in general. And I also did pretty much research on this area, that how much content is there in the YouTube and in journal. So I found that the resources are pretty limited. So uh, I decided to have one series where I will be explaining more about in general the basics of CAD and CAD CAM CAE. But this particular series will be focused on CAD, and then there will be a couple of other series which will cover the simulation, the CAE part, and all those things. Uh, this particular series will be beneficial for students from the design point of view. This will be very beneficial for engineering students, those who want to enter into CAD industry, or maybe they are doing their projects where they are using the tools, a couple of designing tools, and doing their pretty much uh, uh, their projects and having some design things. So it will be helpful for them. It will be more helpful who wants to develop the concept of CAD and in general, and the design concept. The people who are there in the industry, for them also it will be beneficial to understand the uses and concepts so that they can explore multiple areas and see the things, and maybe uh, having a different point of view, and that might help them to improve their efficiency and all those things. uh, yeah, so myself, Suraj Singh Rawat. So I have a good amount of experience into this whole designing environment and in the industry. Currently also I'm working in the development domain, where I'm working in good projects or good platforms where we are developing the platform for whole simulation and designing and all those things. So yeah, so I think I have good understanding, and I want to help everyone to have a little bit of knowledge in this area. So this series is called CAD Industry and CAD Development Explanation, and it will be explanation from a CAD, CAM, and GA development engineer. Yeah, with this, let's go ahead and let me highlight it again that I'm not going to talk about the pretty fancy things like engines and all those complicated things. My agenda is to focus on the basic part, so that once our fundamental foundation is strong, we all have the understanding. Then in the later part, we will deep down into the other concepts. Yeah, so the agenda for this particular part, and there will be, other parts also that are already in the design. I'm already working on those, and I will share them with you. So the agenda is, first I will give you a little bit of picture, what is CAD and where the CAD is fitted, and what are all other areas also there, so that we will have understanding that okay, about which particular part we're talking, and what is the role this particular thing play. So yeah, so it has, then the second will be what is CAD, like what is the meaning of CAD and the use of it. That will be pretty much in the layman language, so that the starting part of it. And we will see the history of CAD development, but I'm not going to talk about the numbers and who patented and what all kind of softwares are there and how they came. I will talk about in terms of design, like from where it started, what was there earlier. We had some subjects in engineering, and then how what is the current phase and how we can map it. Okay. Then a little bit about the CAD industry in general, and if somebody wants to get involved into this industry, what kind of roles are there. And when we say CAD industry, it has two kind of roles that I will explain later. Then we will understand little bit CAD, uh, like in general the work inside it and how to work, and we will see it from two point of view. One is the developer point of view, another will be the user or the designer point of view. So the part where I'm saying that entry into the CAD industry, but once I will explain it, and this development point of view and user point of view is nothing but the little bit deep down of that particular topic. Okay, let's go ahead. So first is design and simulation. So let me go to the draw, and yep. So in general, if you see the designing word, so uh, let's say you have a pretty much uh, there is kind of a container which you want to create, and inside this container you want to fill the water. Okay, and just think about a petrol tank of any vehicle. So for this, what the stages which comes into the picture when any industry design it, or the industry who are owning this part, is how they design it in general. I'm talking first generally what we do is we gather the information about the space, like what kind of fluid is going to get stored into it, what will be the condition, is it a moving part, will it be a stationary one, what is the space we have available, and what kind of loading would be there. Maybe it has a fluid inside it, but maybe there could be some moving component nearby it, or maybe some pressure which will be applied on these surfaces. Okay, or maybe magnetic field or something like that. So that is called first in general, if you understand. So what we will be doing is gathering the information, having a rough design, or maybe I will say a modeling part that we will do here. Okay, so we will do a modeling part here where we are going to create the structure of it. The CAD has multiple stages. Again, there is called the basic one, the sketch one, so where you do a 2D small thing and then you extrude it, or a couple of other operation we do in general, the modeling part, and then you come up with a model. So this is called CAD part. And then once you are done with the CAD, and then what happened is this particular component go for testing or simulation, we call it that. So what happened is we have the model data. What we generally do is we apply the property on it. So when we say property, we will say what is the material. So the first will be the material part, which we will be deciding. Okay, then obviously the material will have a couple of other properties like elasticity, density, and all those things. Then we will talk about the external conditions, like whether it will have some bolts here, or how it is uh, basically assembled, and all those things, right? And then there will be some loading conditions, which will be like what is the fluid inside it, what is the volume, how much pressure will be there in the bottom. So I'm talking about in general like the modeling parts of for the simulation. So this is CAD, this is called simulation, which is called CA. Okay, so sorry for this. Let me erase it. Okay, okay, so this. Yeah. Yeah, so this is called CA, which is basically the simulation part. So here you will apply the boundary conditions, and you will test this model. And then there is it has another part which is called the post processing, where we will be seeing the results, right? So once you got the results from the software, then you will having the graphs, which will be like, you know, the stress versus strain graph, or the von Mises. There are a couple of other things which basically you can talk about the results output of it, like, okay, this part has more stress, this part has less stress, and all those things. And then there are a couple of other things like customization, optimization, sorry, optimization of the. So right now in this series, we are talking about this particular portion. Okay, here we are talking about this particular portion. So I hope you got a little bit idea here. Now go ahead and see the next. So we'll see what is the CAD. So CAD is nothing but a computer aided design. This left bottom model is pretty known for all of us who are in engineering or already in this industry. So there is a subject called engineering graphics, which where we do this kind of 2D in hand sheet drawing. So in the old time, in the beginning of all these engineering era, what engineers used to do, or the designer or architect used to do, is like when they want to design some dam, or they want to design some component, or they want to design some bridges, they have to do all the designing by their hand. So what they used to do is like they used to do all those drawing on a paper by pen and by scale and all those things. So they used to do all these drawings here. So this subject, this was easier, and it was the only tool at that time, and it was very time consuming, very bulky, and because multiple people or very large number of engineers work together, so the collaboration part, and if something has changed in one area, how it will get mapped, because manually you have to change everything, and it was very much there was a huge number of the probability was that probability of error was very high. And these seeds were generated, and then they were supposed to move to the manufacturing side, and then they follow it, they see the uh, individual aspect and individual area, individual view, and then operate on the machines and run the machines with that particular specific specifications and get output. Um, but that was not very efficient. So now what is happening is, right now the whole responsibility is now taken by the computers. So the computer has the intelligence to uh, deal with these things. So what it does is, instead of having these 2D sheets with you, having all those view manually, all those things, there are softwares and there are computers. There are softwares, and the computers will help you, where you can just go and give the command to the computer, or maybe draw something on the computer, ask for other attributes, and it will help you to generate those things. Maybe store the data, do the designing part in the background, do the mathematics, and help you to do all those operations with pretty fast, with very less errors and high precision. So that is how the computers are basically helping the humans to do all these type of things. It helps you to visualize the things into 3D mode also. Like, you can see the component, you can rotate the components. If you design something called as maybe a cylindrical rod or something, like, you can rotate it, you can see from the different view, you can apply materials on it, and it helps you to do the operation pretty fast. Okay, so this is how the CAD is evolved out of the problems and the real world challenges. Okay, and I think this is pretty much about the basics of the CAD. So instead of doing this thing by hand, and now softwares are there, you do there. So you're doing pretty much the sketching part on the screen as well with the computer. Okay, let's move ahead. And yeah, I already explained it a little bit in the earlier slide, but this was the drawing we used there. Now we'll see it again. So this is pretty much the engineering graphics things, what I just told you. The history of CAD development is like, not talking about in terms of the years and who invented which tools and who generate which, who patent which softwares and all those things, but I just want to explain you guys that you can see that on the right side it's basically CAD tools. When I say tools, it's basically software or the capability of a computer. So instead of having these drawings by hand which are there in the left side, you want to see it from top, you want to see it from the bottom, and maybe you might have a question that why you want to see it from the top or bottom, because let's say if you have, I will take the example of cylinder itself because pretty much easy to understand. So if you want to have a cylinder which has some particular diameter or radius and you want to manufacture it, so what happens is when you go to the shop floor, or you connect with the manufacturing team, they will ask you, give us the specification. So when you say specification, they need 2D drawing. So what they need is, they need a cube from the top. So, okay, so it will tell you that, okay, it has a diameter called maybe 4 centimeter, and then from the front it will give you a rectangular kind of shape. So yeah, you will come to know that it has a length of 5 centimeter. So this is the requirement they need, and there are a couple of other things we denote, like the surface finishing, which is there. Then there are uh, the density. There are other things also. There are, so those things are there. So we have to pass it to the actual manufacturer team, and they will adjust their tools according to that and get output. Before the CAD, what used to happen is, like, we design the things, go to the manufacturer, manufacture it, test it, and then it fails again, go and do all those iteration again and again. But with these tools now, the industry is moving very fast because they don't need to spend a time on the manufacturing in the beginning. So what they do is they do all kind of testing, all kind of designing, the precise one, the optimum one, all the material testing part, and everything they can do in virtually. Even they can see the simulation, like the real their world operation of the tool or the object in the machine itself, in the computer itself. And then finally, once they're satisfied with the results, go and manufacture it. So the probability of failure is very less because you already got the idea about its behavior. Okay, let's go ahead and so yeah, so this is the history part where I was just my agenda was to show you that how this manual work are now handled by computer, which is called a CAD tool. Okay, yeah, okay, so you might have, I think we already covered the use, but let me explain it again. So use of CAD is nothing but yeah, so on the left you can see that I've taken a very basic component, a very known familiar component which is everywhere in our houses. They are the lock, they are the basically those locks which are there on the doors. So as I already told that we are not going to see the complex part in this in the beginning. So let's go with the basics. So when we have this log, if you think about not having a CAD tools, what happen is you might we used to manufacture them, do some pretty much initial stuff, do manufacturing whatever material we have. Maybe we are using a very high cost materials, uh, and we go there, manufacture it, test it. Sometimes it fails, sometimes it doesn't fail. So and then go again and do those processes. It basically sometimes it seems like a very uh, not a very optimum way of doing things, because if it is failing, then you will be spending a lot of money on that, because you manufacture one part in with one specification, go test it, fail again, make some changes, test it, fail again, make some changes and test it. Treating one cost wise not efficient, efficient basically time wise, the manpower and all those things, it's very high. The requirement is very high. So with the CAD tools, what you can do is, like, you can have a virtual design of it. You will ask pretty much the basic questions like what is the use, what is the loading part, or basically the surrounding environment where I'm going to use it. On the basis of that, you can make an initial design, like all these diameter and handles and all. Check check with, like, whether this design is fixed, or is it the length is unnecessarily large or the handle, and you can change it on the software itself. You can reduce the things. If in terms of CAD, this is what we do, but there is a role of CA, like the simulation also. So what I mean is, like, at the same time in the software, you can apply the conditions, like what will be the force which the user is going to apply on this handle, what is the use, whether it will be there in some moving component, or it's something like very light use. If it is light use, then you can the software itself tell you that okay, your boundary condition or the loading condition is pretty low, so you can go with some other material which are not that costly. So basically the optimization is happening in the place itself. And with the space one also, you can see that okay, this much space is handle is taking right now with my model, what is the space there in the door, and with this you can change it and just see that whether it is satisfying the overall thing. And with this, what I am trying to explain is like you can do all type of designing part on the software itself and come up with the model which will be the final one, and it will be uh, satisfying all the loading things, all the user things, the space one, it will be the best fitted as per your space, and it will not be over engineered, it will not be under engineered, it will not be having unnecessarily uh, high strength materials which is not required, or maybe should not will not have a material which is below the mark. So it will be the optimum design. That is what the whole purpose of the CAD tools are, like having a design before even going for manufacturing, test it. Okay, so that is what the use of the CAD is. How it gets generated, how we do it, and that is the later part. We will see how we do it. Planning to have a part on that as well, where I will say that when it comes of designing some basic things, what all things and how we go in general in the industry. Okay, so the next part is that, when I say that what all ways we have, or what all areas we have in the CAD industry where we work. So it's mostly about the CAD environment. So when we say that I want to go into the CAD, I'm a CAD designer or I'm a CAD developer, what it mean is like uh, there are engineers, there are people in the CAD who actually design the component on those tools. So they are the people who use or these CAD and simulation softwares, and they do the designing part, like the companies who design the tractor, the companies who design the ship. So they have a team of engineers who actually uh, work on their specifications, work on their particular problems, and design those component on any of the software tool, any of the CAD tools or CAD designing tools or modeling tools, you can call it as, and come up with the results. So the tools, they feed all the requirements, like they say that what is the diameter is there, what is the whole component structure is there, and what are the load condition. And then the software tells you, okay, on the basis of these load conditions, these are the outputs. So this model is pretty much known for all of us. So let's say you have a bar where there is a 10 newton force going to get applied, and there is one side which is fixed, pretty much very familiar statement. And obviously this bar will have some properties, like it will have density, it will have elasticity, and all those things, thermal conductivity and all those things. So this is the engineering problem, this is the real world problem. Now how this problem is getting solved by this CAD is like, on the left side there is CAD user or designers. So a couple of you might be interested on this part. So these engineers, what they do is like they see the problem, they design the problem on the software. So here you can see that if the person is basically designing it on the software, so he might not be very aware about how the the software will solve it, but he know that what he wants to feed here on the basis of his specification, on the basis of the project he's working, or the organization for the organization he's working. They might be from the aerospace, they might be from the ship marine, so they want to design some particular component. So he will say that, okay, I have a component like this, it will have some force in this way, it has some part which are fixed, I don't want to let them move and all those things. So these are the CAD users, they are using the CAD software, they are the designers, so called. So they go and they design, they mimic it on the software. Okay, so then there is a second part about the CAD is like people who, so obviously if you are working on the software, you feed the software, you give him the inputs like, okay, this is the space, this is the dimension, this is the loading, tell me what will be the results and how it will work, or tell me what material will be best suited. Obviously there will be in the background, the computer should have the understanding and should have the logic, should have the mind to work on it. So that is called development of it. So obviously, if you have, let's say, a platform where you are designing a whole component, so as a designer, you design it, you use the interface, you design things, you put all the boundary conditions and all those things. So yeah, as a designer, you already design it on the software, but now the software is going to respond on it and doing the mathematics. So there is a people or the engineers who work on these algorithms who basically so all these engineering concept, all these equations, all those mathematics which we have in the field, like the theory of failures and all those things, the transformation, the matrix, dot product, cross product, all those things. If I just talk it up, a very basic one, but whatever is there. So you say that I have this load, I have this material. Obviously, you have to going to apply the stress strain concept and see what is the elasticity there, apply it. So basically, all the equation things which we used to do manually, now the software is going to do it for you. Obviously, there will be a team who will be writing those algorithm in terms of in the language of the software. So there is called a CAD developers who are the engineering people who understand all the mathematics, who understand all the equations which is there in terms of engineering concepts. And then what they does is, here I have represented very basic. This is, trust me, it's very complex area, but when you go, it's very interesting and very big area. So there are a lot of things happening, and there are a lot of things happen for having one solution. So it's mostly like the people who they understand the concepts, they understand the mathematics, they understand the equation, they understand the graphic things, they understand everything. They understand computer, they understand engineering, and then they write the instructions. So they write some set of algorithms which get converted into machine language, and that in general get fed to the software or fed to the computer. And now once the user or the designer interacts with the computer has the mind, it has all the information, it has all the equations. He say that, okay, I have these scenarios, let me know. It does the mathematics in the background, come up with the solutions and show it to the designer. Now there's that when I say the CAD developer, they are the developers who actually develop those algorithms. So they translate basically those engineering concepts in terms of machine. So yeah, so these are the concepts. I will be explaining it later how these things are there. But let's say this is what the instructions are written, all those equations are written, and it will be converted into machine, and then it will feed into the machine. Now, once person interact with the machine, he say that, okay, this is how the component looks like. This is the boundary conditions, and let me know. And then the computer will solve it and say, okay, here this part is going to get bent. Here this part is not very strong. Please change the material. And the person will say, okay, I need to change the material. He will change the material, test with other material. So this is how things goes in general. Okay, and I have written it here, this one, CAD CAM CAE. Sometimes the people who are from mechanical background, they say that why we should go into software development and all those things. So the software language is one way of conveying it, because obviously you are dealing with machines, you are dealing with computers, so you need to know the languages the computer understand. But this is not what the CAD developer do. The CAD developer are the people who are very strong with the engineering concept, who are very strong with the designing concept, who has a very strong analytical understanding, mathematical geometry, and all those things. And then once they're done with their research, they're done with their equations, then they say, okay, I need to feed to the computer. So I need to know how the computer understand, and then they write it in these languages. And there will, in the future there will be a couple of other languages, like if there are other tools or the platforms, and then obviously if there is mobile, Android is there. So obviously if I want to uh, give this intelligence to my mobile, I need to understand the mobile language, which is the mobile development, which is Android and all those things. So tools are there, but this is not how the definition of CAD developer is. Pretty much vast and great opportunity, a great research work, excellent area for people who want to know math, who want to know design, who want to go deep into research part. So this is how the area is. Okay, and I hope you guys got the idea about it. In the next series, in the next part, I will be go a little deep and see what all things are there, and maybe I will see on the basis of your comments and your suggestions, we can go into different areas, different discussions we can do, what all things are there in the CAD, how we can enter, what should someone prepare for getting into this industry, and other things. So in general, if you want to know more things, please let me know in the comment section, and do share this thing with your friends, with your with your colleagues, and everyone who are interested, who has this kind of interest or are already working in this area. And if you find it beneficial, please subscribe so that the coming channel, the coming topics which I'm going to create or explain, you will get the notification. And I hope and I wish you a great learning. All the best. Thank you.